Good evening, and welcome to the General Society of Mechanics and Tradesmen of the City of New York. I am Karen Taylor, Program Director of the General Society, and we are so pleased that you can join us online tonight for this lecture. I would also like to express our thanks to the New York Landmarks Conservancy for their support of this talk, and I'd also like to express our appreciation to Beth Bailey for all her work in setting up this talk tonight. So thank you very much, Beth. For those of you who may be less familiar with the General Society, a brief overview. The General Society was founded in 1785, 237 years ago, by the skilled craftsmen of New York City. Our 237-year-old organization continues to serve the people of the City of New York through our educational and cultural programs. These include our General Society Library, our John M. Mossman Lock Museum, our tuition-free Mechanics Institute. And by the way, I do want to mention that our speaker, Raymond Pepi, was actually a student of the Mechanics Institute. He has been through our doors a couple of years ago, but he's certainly been here in our building. And finally, our lecture series. And this is a lecture series that was originally started in 1838. And of course, tonight is part of that tradition. For the audience, please feel free to submit questions at any point during the lecture, and of course, at the end of the lecture. But we ask that rather than use the symbol to raise your hand, that you submit your questions through the Q&A step. I am so pleased to introduce our speakers tonight. First of all, Raymond will be speaking first. Raymond Pepi is the president and founder of Building Conservation Associates. BCA has been in practice since 1985, and over the firm's 37 years, it has become renowned for architectural conservation and preservation planning and applying historic research and forensic analysis to design the restoration of some of the world's most important buildings. Our second speaker, Laura Buchner, is a senior conservator at BCA and has been at the firm for 17 years. Laura has served as project manager at St. John Divine for the past 10 years and has been involved in the restoration of the Akoustolith vaults at several other sites, including the Grand Central Terminal, Oyster Bar, and the Whispering Gallery, and St. Patrick's. Laura has spoken at several conferences and has written multiple articles for the APT Bulletin, including restoration of Akoustolith tile at St. John the Divine, New York City. And she's also the 2022 FAIC Samuel H. Kress Conservation Publication Fellow, and is currently writing a book manuscript about the history, fabrication, and preservation of Dalle de Verre. It is now my huge pleasure to introduce to you Raymond Pepi. Raymond, thank you.
Okay, thank you, Karen. Laura, will you take control? Let's see here. Okay, great. Okay, good. So hello to everyone out there, and thank you for joining us today. Laura and I are excited to have this opportunity to delve into one of our favorite subjects, Guastavino vaults. Many colleagues have contributed to our knowledge over the years, and we wish to thank them, first of all. Their names will appear at the end of the lecture. A lot of information now exists in print and on the web, thanks in large part to John Oxendorf, an engineer and educator who has written and lectured widely on Guastavino construction. So although this talk contains some background and history, the focus will be on the Guastavino vaults at the Cathedral of St. John the Divine in New York City. In addition to the cathedral, our firm has been involved in the study or restoration of other Guastavino vaults, including the Oyster Bar at Grand Central Terminal and St. Patrick's Cathedral. Some of you may be taking this for AIA continuing education credits. And if you are, then we'll provide certificates of completion. And for the AIA credits, we have 4 learning objectives. The first one is understanding the history and evolution of the Guastavino company and the various vault finishes they employed and the methods used to construct the vaults. 2, understanding the construction history of the Cathedral Church of St. John the Divine. 3, understanding the typical factors involved in and mechanisms of decay affecting vaults. And 4, understanding the general complexities associated with conserving and restoring Guastavino vaults. The Guastavino company contributed to the construction of more than 1,000 significant buildings in the US. The Cathedral Church of St. John the Divine in New York City is unique among them, as it was constructed in multiple phases over a period of nearly 50 years, spanning approximately 2/3 of the period that the Guastavino company was in practice. And here is our main protagonist, Mr. Rafael Guastavino. He immigrated with his son, Rafael Jr., to the United States from Catalonia in 1881, bringing with him the knowledge of Catalan vault construction. Guastavino referred to it as timbrel vault construction. And you can see the general dates of his, his birth and major milestones. We'll talk a little bit more about some of these dates during the lecture. Guastavino is often credited with being the inventor of tile vaults, but that's in the United States. And he was ingenious figuring out ways to deploy tile vaults in contemporary buildings. But the concept was hardly new, as tile vaults made their first recorded appearance in the 14th century in Valencia and Catalonia. Guastavino became, however, the agent for this important technology transfer. So here are the main characteristics of tile vault that Guastavino deployed. They were light in weight, fireproof, could be erected faster than the typical Roman vault that was in common practice, using large stones or bricks. Involved a lot less material, so it was more economical and without sacrificing strength. It was thinner in section, and the vaults could be relatively flat or low profile so that you could save space within the building. It could be erected without false work or centering to support a vault while it's being constructed, therefore suitable for high vaults that would be hard to erect centering for. And the outer tile can be decorative. The tile that you see when you look up, that can be decorative and left exposed, but it is part of the structural system with no need for further decoration. The story of Guastavino vaults in America really gets going in 1889, when Guastavino, who was a master builder trained in Spain, obviously, convinced Charles Fulham McKim to incorporate his fireproof tile vault system into the design of the Boston Public Library, already a year into construction. So what could be so compelling that a recent immigrant could change one of the most important architects in America, McKim, change his design for such an important building almost literally overnight? As in all construction, the reason was lower cost and a faster schedule, amplified by appealing aesthetic possibilities, which were taken advantage of at the library. The thin shell vaults comprise 3 or 4 layers and of the tile laid flat in a herringbone pattern that could be constructed without the need for elaborate wood centering, as I mentioned. In fact, the vaults could be constructed from either above or below, which was a breakthrough. This departure from traditional vault construction was so stunning at the time that it catapulted Guastavino to the forefront of architecture and building in the following decades. He also realized that to eliminate supply chain issues, he needed to manufacture his own tile. So he patented new ceramic kilns and set up a factory in Woburn, Massachusetts. His company so dominated tile vault construction in the United States that timbrel vaults, as he called them, was effectively a one-company industry from 1889 until the company dissolved in 1962. I'll just call your attention to the lower left image, which shows more or less conventional arch at the Boston Public Library, constructed out of stone, but with the wood centering supporting the arch. until everything's set up. And the photograph on the right is from also from the library and shows a Guastavino vault, and it shows how thin it is. That's 3 layers of tile, but it's quite thin, and it doesn't have any centering. Here's an illustration, a diagram, further shows the difference between these 2 vaulting systems. In the upper left, you can see a conventional vault comprised of heavy masonry, could be stone or brick turned up on edge, and below it stacked tile Guastavino. So the tiles were just kind of like overlapping each other in 3 layers. So what were the choices open to architects and builders designing or building vaults in the last quarter of the 19th century? One of the most celebrated and well-known authorities of the era was Viollet-le-Duc, a French restoration architect and theorist whose dictionary and discourses influenced architects of the period. Although he was obsessed with light construction, there is no mention in any of his vast writings of thin-shell tile vaults, at least that I've been able to find. His designs relied on steel or iron to reduce the masonry load, as shown in the left image. And the right image is a room under construction at the Boston Public Library on the upper floor, where thin iron framing would eventually support finished plaster that would be painted. By the 1930s, the Guastavino tile arch system was recognized in the mainstream press for all its advantages, but this blurb in the fireproof chapter of Kidder Parker, basically, I don't know whether you guys can see me, but that's this book, basically recommends contacting the Guastavino company, acknowledging the sole source of Guastavino vaults. In the same chapter, Kidder Parker provides other composite systems, steel and terracotta or brick for floor arches, but does not mention Guastavino's potential for domes or circular vaults of all sizes and shapes. The age of steel and concrete were overwhelming Guastavino's quaint tile system already in the 1930s. Given how novel the technique was, Guastavino had to repeatedly prove that his vaults were structurally sound to authorities. Today, structural engineers can analyze vaults using computer-generated finite element analysis. Slide shows a pile of brick sitting on top of a vault, which is a little hard to see, at the Boston Public Library. And it passed all the tests that were required of it. Until the Boston Public Library Commission, all of Guastavino's vaults were plastered over and painted on the underside. Here at BPL, for the first time, he developed a system for decorating the exposed soffits of the vaults using glazed and unglazed tile and geometric patterns. He worked a lot of this out with the architect, but it was a very successful enterprise. Reflecting the importance of fire protection, the company was incorporated as the Guastavino Fireproof Construction Company. And Rafael Sr. gained increased attention and notoriety when he presented the first of 2 lectures at MIT, and his second was in early 1890. These were later published as a monograph in 1892 called Essay on the Theory and History of Cohesive Construction, a term that he employed. By 1892, the company had opened offices in New York, Boston, Providence, and Chicago. Guastavino was becoming closely associated with the City Beautiful movement in Beaux-Arts architecture and architects. Due to the 1893 economic depression, the company was forced to reorganize, and in 1897, it became the R. Guastavino Company, with Rafael Jr. named as vice president, as he was gaining vast experience and capability. And in the early 1900s, his dad, Rafael Sr., went into semi-retirement, and Jr. took over operation of the firm and did very well with it, equally as important as his father. Although Guastavino's tiles could be installed without centering, it's clear from this photo at the Boston Public Library that sections were temporarily supported with wood templates. Perhaps not in every case, but in many cases. These also serve to maintain the desired radius and were apparently moved along as the tile set. These patterns, these wood patterns, could be removed before the vault was completed, unlike a conventional vault. And here are a couple of other photos that show in the foreground the wood templates, and in the background the Guastavino vaults that were constructed based on their radius. And here's another one where the wood template is engaged and the tile is still sitting on top of the wood template. So they would just remove a section and slide it along until they got the radius correct. Guastavino received a patent in 1881 for a system of constructing vaults using thin tiles. This patent drawing clearly shows no need for false work and how the system is distinct from conventional arches where, unlike Guastavino's system of laying tile in a flat orientation, the brick is laid up in a vertical position. That's in the lower image. And the upper image is Guastavino's system. The tiles were assembled in layers with fast drying mortar to create monolithic assemblies. You can see that in the diagram, and in the right photograph on edge, you're looking at a profile of the multi-layered tile in an arch. The Guastavino company published elaborate details, such as this page from the 1929 Suites catalog that's in BCA's library, as it happens. But because of the patent he held a virtual monopoly on the vaulting system. There is a wealth of information in this cut sheet, notably that the vault could be built under a concrete floor. See the blue arrow, and the red arrow illustrates the use of dwarf walls, suggestive of the construction system above the Oyster Bar and Grand Central Terminal, supporting the original waiting room marble floor. So in the right series, you can see the red arrow pointing down, and below it is a shop drawing from the original construction drawn by Guastavino. So that is the position of the vaults underneath the waiting room floor. For those of us in New York City, examples are not hard to find of Guastavino vaults. In fact, once you become familiar with the form, they seem to be everywhere. Recognizable by the herringbone pattern, low profile, that's relatively flat profile when in some cases, and spanning large areas without any visible means of support, with the tile serving as the finish of the structure. So no need for painting or plastering. The tile is part of the structural system and can be used in the last bottom layer of tile as a decorative tile. The left image is of a steakhouse on 34th Street, and the right image is of the Queensboro Bridge Market, both incredible spaces that are worth visiting, especially if you're hungry. The architect for New York's first subway was Hines and Lafarge, who were also the original architects for St. John the Divine. August Belmont, a financier, was head of the subway and a patron of St. John the Divine, and hence there is a connection there, which Laura will describe in greater detail in a moment. The subway, which ran north from the City Hall station, was completed in 1903. And it's under City Hall Park and was referred to as a subterranean cathedral, consisting almost entirely of polychrome Guastavino vaults and stained glass, all designed to elevate and overcome anticipated public resistance to traveling in underground tunnels. The station survives to this day and is still used as the loop turnaround for the number 6 train before it starts on its journey uptown. But the station is sadly not visible to the riding public, but the conductors have a view of this magnificent station every time they drive the train through it to turn it around to go uptown. More views of the City Hall subway. The left slide shows an unresolved detail, since you can see the arch tile on edge, and it's a little bit rough. And the slide on the right shows the tile cross-section consisting of 5 layers supporting masonry above. Both of these are at City Hall. The Cathedral of St. John the Divine is famous for its size and for not being completed. In fact, the Guastavino Dome, which is a masterpiece of 20th century masonry vault construction, was intended as a temporary solution for covering the large crossing until a final spire could be constructed. This poses a preservation conundrum for future generations, since the dome is now a character-defining feature of the church. In the meantime, its preservation is of the utmost importance, and in fact, an investigation of the dome by BCA, Silliman engineers, and Ennead architects is currently underway. Laura will tell you more about this in a moment. The Guastavino company is gone, but contractors have figured out how to reconstruct tile vaults when necessary. Here you can see two missing Severies at St. Patrick's Cathedral in a vault underneath the Lady Chapel. It's part of the crypt, but it was built in around 1905. So it was an addition to St. Patrick's Cathedral, but nonetheless, it was a Guastavino vault. And during the most recent restoration, which we were very much involved in, there was a need to remove a couple of the Severies for structural purposes to support something above it, and it had to be reconstructed. On the left, you can see restoration in progress. Bent steel bars were temporarily installed to serve as guides for the geometry of the vault as they installed new tile. And the right slide shows the new tile already installed. Post reconstruction and there was some painting required in order to match the adjacent tiles, but this is the space underneath the Lady Chapel. At St. Patrick's, the vault soffits were finished with glazed tile, but over the years, Guastavino utilized a number of finishes to decorate their vaults, including those shown here. Also shown at the top left is a portion of an unglazed red tile used for construction of the structural vault, to which finished tile were applied. Before turning to the cathedral, let's take a quick look at how vaults at the Oyster Bar at Grand Central and the Whispering Gallery right next to it were restored in 2013 and 14 under our direction. The restoration was precipitated by isolated areas of mortar having fallen out over the years. As a result of a comprehensive inspection, the tile needed to be either repointed, anchored, or reset. The Oyster Bar is a magnificent space and still an active restaurant. The Oyster Bar is in the lower part of Grand Central Terminal. You can see the blue arrow pointing to about where it is. So this is a cutaway looking east, and 42nd Street is on the right. Here is the entrance to the Oyster Bar in an area that's called the Whispering Gallery. So if you stand in one squinch or one corner on the left or the right, and you whisper, someone 50 feet away in an opposing squinch can actually hear you. This was unintended, but is now a major tourist attraction. So when it became necessary to replace most of the outer tile in the Whispering Gallery, great care was taken to recreate every aspect of the original: the tile density, the size, thickness, mortar, etc. And the curious sound effects were indeed preserved along with the Guastavino vaults. Comprehensive sounding of each tile was the technique used to identify loose tile. Here is an image where a few tiles were removed before the restoration. And now if you follow the red arrow in the upper right diagram, as I click through the sequence, it'll be very helpful to understand what's going on. The soffit tile was the first layer of the vault that was assembled. These were bound together using a soft white mortar shown by the white arrows. So the lower tile was installed first, and then it was bound together with like a gypsum plaster, which set very quickly. And then above it, the rest of the tile were installed. So I'm going to cycle through it now. So the next layer after these units were laid, a gray mortar was buttered on the back side of the tiles, of the first layer of tiles, the lower layer. And then next, and then another layer of red backup tile was installed on top of them. The red tile looks like common quarry tile. Additional layers of gray cement and red tile were then built up to form the total vault system of 3 or 4 layers, depending on what was needed. After construction of the vaults, the soft white mortar that we started with between the tiles was cut back in preparation for the final mortar, which was a ribbon mortar, which is kind of like a mortar that sticks out from the surface a little bit. On the left, you can see an area of tile after the raised mortar was removed during the restoration. A tan-colored raised mortar joint was then installed for our restoration. Note the dark areas waiting to be restored at the bottom. So it's like a little bit of a before and after. And here is a close-up of a vault partially repointed during the work. At the bottom of the image, you can see tiles not yet pointed. A raised or ribbon joint, but you notice that the tile, they don't have registration perfectly next to each other because it's flat tile being installed on a convex or concave surface. So the ribbon joint, which sticks down a little bit, is essentially a method to disguise the inevitable misregistration of flat tile laid on a curved surface, and it works. This image shows the mortar being installed, the final pointing mortar, the ribbon mortar. It remains unclear how Guastavino installed the mortar, but we suspect similarly with the same aesthetic effect. Achieved as the workers filling the joints with mortar used a caulking gun and then a special tool for striking the surface. When the mortar was sufficiently set, the excess was cleaned up and from the surface of the tiles to form a nice clean profile. And you can see that at the top of this image. The finished product and what appears to be a smooth and continuously curved surface that was affected by the ribbon joints is shown here. This is a restored part of a whispering gallery. So that's a quick description of Guastavino and how to repair it. So now it's my pleasure to hand off the second part of this talk to Laura Buchner, who is a senior conservator and project manager at BCA. Laura?
Hi, thanks, Ray. So talking about the Guastavino at St. John's and focusing on that now, what's impressive about it at this site is not only the sheer quantity of it, which is really remarkable. Essentially, Guastavino tile is found throughout the entire floor and the entire ceiling of the cathedral practically. But it's also really fascinating to look at this site because as the construction evolved at the cathedral and the design evolved, it also mirrors some of the evolution of the company. So we'll start back with the cathedral in 1889, which is the year that the Boston Public Library was constructed. So this is happening concurrently. They're just really starting off in this country. The cathedral received 60 sets of competitive designs, narrowed down to 4. All of these designs had Gothic traits, but none was really purely Gothic. The winner of the competition for the design was the firm Hines and Lafarge. And they were selected in 1891, the same year that an 11.5 acre for the cathedral was purchased, which is located between 110th and 113th Street, Amsterdam Avenue, and Morningside Avenue. You see highlighted in red on the screen. Now, although the exterior of the Hines and Lafarge design was English Gothic, the interior was really rooted in Byzantine domed churches. They had a design description that discussed at length their reasons for including domes and rounded arches rather than Gothic style vaults. They noted that very few churches in the United States actually had real stone Gothic vaults. Most were just painted plaster to imitate stone, which they just didn't feel was in keeping with the philosophy of Gothic architects. If you want to see a beautiful example of this sort of thing, you can go back to St. Patrick's, which has the beautiful painted plaster faux stone. Instead, they were advocating to construct with what they referred to as tile arch construction. They didn't use actually the word Guastavino anywhere in their description, but that's really what it was. They wrote, it consists of building an arch of tiles laid at right angles to the radius of the arch. This method, although only lately made available in this country through the importation of workmen familiar with its use, is one of highest antiquity. The flat tiles of which it is built overlap each other like scales of a fish, and being laid in cement, form practically a homogeneous mass, which exercises practically no thrust on its supports. They explained that using this tile construction would allow the piers and the buttresses to be made less massive, which would of course be an economic savings. Similarly, the tile vaults could be lighter and easier to build than using traditional stone Gothic vaults. They went on to note that the interior of these surfaces could be decorated with any degree of elaborateness. Their intent was to use colorful tiles and mosaic finishes. It is interesting to note that they additionally described, Gothic vaults as discontinuous by design. They're broken up by projecting ribs that carry the stones. And with the tile arch construction, the strength of it was really considered to lie in large continuous surfaces. So they reasoned that this method was best used for tunnel vaults and domes with pendentives like you see in the design here, rather than Gothic vaults. And as you'll see over time, obviously Guastavino's construction was used to construct many other Gothic vaults. But the cathedral first cornerstone, it was laid in 1892. Excavation for the foundations proved difficult though. In some areas, they had to dig over 70 feet for solid rock. By October 1898, Guastavino was at work though at the cathedral, constructing the crypt vaults. They formed a chapel, which was used for the first services on site in January 1899. The vault space here was about 18 feet high, about 100 feet wide and 70 feet long. And the services were held here in the crypt without interruption until the choir and crossing above opened in 1911. Guastavino Sr. initially constructed with tile that he purchased from others, but pretty early on, he became frustrated with reliable, affordable tiles, securing those. So in 1899, he submitted a patent for improvements in kilns for glazing and enameling clays. And then in 1900, the company began manufacturing their own tiles in Woburn, Massachusetts. And that enabled them to explore new colors and patterns. You see one of the Guastavino tiles here on the screen, which is actually removed from the oyster bar. Not all tiles they made have this background design in which you can see the arch across the top and their name in the back of it. It's always kind of a treasure when you get to find one of these. But just an example of their product. Now, not long after opening their factory, Guastavino began working on the first of 2 apsidial chapels at St. John the Divine. So there are 7 chapels that wrap the east end of the choir, and they're referred to as the Chapel of the Tongues. Each chapel is dedicated to a different saint that represents a major population coming through Ellis Island at the time. So the far east chapel in the center is Saint Savior, which highlighted on the screen. This has groin vaults that are decorated with glazed yellow and green tile. You can see here at the top, except over the altar with these beautiful gold mosaics. The chapel here also exhibits those decorative raised mortar joints that Ray was mentioning. Guastavino Company first employed those on their vaults in 1905 elsewhere. Ray mentioned a connection to City Hall. To give you a context of what was being constructed at the same time by the company, St. Savior was donated by August Belmont, who was head of that consortium building the subway. The first tile order for St. Savior was placed on November 13th, 1901, just 5 days after the order for City Hall subway station. Company records indicate that the green glaze ordered for both is the same, which is just a fun connection. The second chapel that was built by Guastavino is St. Columba, highlighted again on red on the screen. Now this was built later than St. Savior. The first order for tiles was in 1906, but both chapels were consecrated in April 19th, 1911. The ceiling of St. Columba is comprised of vaults with a more traditional plaster finish, except again over the altar that has those beautiful mosaics. Both St. Savior and St. Columba, in addition to having ceilings by Guastavino, had roof structures that were constructed by the company. Now, Heinz and Lafarge's overall design for the cathedral was really intended to showcase mosaics and tapestries, various marbles, really colorful floor tiles. And you get that sense looking at the finishes for those 2 chapels, as well as the floor of the choir here. The original ceiling in the choir area also had that yellow and green soffit tiles. You have these beautiful staircases in the ambulatory that rise the full height of the choir. They don't have a central access. These stairs by Guastavino are also quite remarkable and just again with that colorful tile. Above the choir, Guastavino is also responsible for the attic, the roof structure. They built the arches that spring above to form that roof, which was constructed with hollow box sections of tiles. The safety of the roof design was verified using a method called graphic statics, which is an analytical technique that was regularly employed by engineers by the year 1900. Guastavino Jr. had first learned graphic statics, constructing the nearby St. Paul's Chapel at Columbia University, completed in 1907. And the use of this technique was employed in future constructions, including the dome of the crossing at St. John's. In February 1908, Rafael Sr. passed away. In 1909, the next year, Guastavino Jr. was responsible for building what is the largest dome ever built by the company. You see a popular advertisement on the screen, which shows a number of the domes they constructed with St. John's at the very top. It spans 135 feet. It includes an area similar to St. Peter's in Rome and the Duomo in Florence. The dome was constructed, though, to be temporary. It was only intended to enclose the space until funds could be secured to pay for construction of the spire. It rises 161 feet, 2 inches. The granite arches were first constructed, and then the tile dome was constructed without any falsework support. You see wood templates, as Ray mentioned, but no supports underneath it. There was a scaffold built on the outside of the dome that helped support essentially really just mixing materials. The workmen themselves were supported on the tile they were constructing. So thinking back to that explanation that Ray gave about how the vaults at Grand Central were built, that first layer being with tile that was put together with a really fast drying mortar, that white mortar. So that was done here with then the subsequent layers built above it. So looking at an interior of this dome, think of each ring of these tiles as a course. In one day, 3 courses of tile, so 3 rings of tile were constructed. At the base of the dome, it's 9 tiles thick, so about 12 inches. At the very apex, it's only 3 tiles thick, so about 3 3/4 inches at the very top. The productivity of laying just 3 courses a day was dictated by the fact that 3 courses is about 18 inches, and that's about far as someone can really reach out over the edge of this dome, lying on top of their previous day's work safely. So at the beginning, there was a large work crew to get done that thick tiles, these large rings. And then by the time they got to the top, they only really needed about 4 masons. They could easily finish in 8 hours, and they just had to wait to the next day in order to be able to have it support them. They maintained that curvature with a device that was designed by Guastavino Jr., which is pictured at the right here. So if you follow those red arrows, this will help make sense. The center of the dome was established with a plate that was about 6 inches square, that had 4 turnbuckles with steel wires attached to it at each corner. Those were anchored to the granite arches that carried the dome. Then a vertical bolt at the center of the plate was connected to a steel rope that had a heavy weight hanging from it that was placed at the very center of the dome. And that was confirmed at the center of the dome once or twice a week. Then you had additional wires extending up from the plate, and those were moved along with the templates in order to maintain that radius. This is reportedly the first dome in which the company integrated steel bars between the courses. You see on the right actually an image from the Oyster Bar kitchen where in 1997 a fire there had been the tiles removed. And you see above that the steel reinforcement embedded in the mortar above, which is an example of this. Now, it just took 15 weeks to construct the dome at St. John's. The work was said to be completed without accident. Only 1 or 2 tiles fell. The pendentives, which are this triangular portion here, those pendentives were constructed in 5 weeks, and everything above the arches here was constructed in just 10 weeks. The work garnered substantial media attention, as you can imagine. At the time, it cost $10,300 to construct, which would be equivalent to about $321,000 now. We talked to one of the preeminent restoration contractors in the country and asked them how much they thought it would take, and they said at least $10 million to build now for them. So really quite the bargain. The dome was warranted for 10 years. About 7 years after its construction, it required its first repairs when a survey showed that the dome had started to flatten. So Guastavino had it bound on the exterior with some iron bands. In 1927, it needed netting installed underneath due to small bits of mortar falling. In 1937, Guastavino did some additional repairs to the pendentives. Despite the need for these interventions and other maintenance, this temporary roof has been in place for over 100 years. Most recent intervention was the installation of a new copper roof, recently completed. If you visit the cathedral now, you'd see a large crossing, scaffold in the crossing for an interior restoration of the dome that's about to commence. Now, by 1911, the first services were held in that crossing and apse. On the screen, you see the section that was built by 1911. That was designed by Heinz and Lafarge. By that point, Heinz had actually passed away. The cathedral decided to engage a different architect. Architectural taste had really shifted more towards the Gothic. And so they appointed Ralph Adams Cram of the firm Cram, Goodhue, and Ferguson as the consulting architect for the cathedral, which at the time was a very controversial decision. It effectively marked the end of Lafarge's involvement with the cathedral itself. But Guastavino Company would be no less integral to the construction of the building. Cram's new vision for a monumental, purely Gothic structure relied heavily on the company's technologies. The trustees accepted Cram's new design for the nave in 1915. Construction began a year later. Now, during that period of design, 1911 to 1915, Guastavino was still active in the construction of other buildings on the close. They were also building floor vaults and roof structures for 4 of the other obsidian chapels. So they were still working in this design. During this period, they were also developing new finishes that would be integrated into the cathedral. The company had worked with Cram, Goodhue, and Ferguson elsewhere, and they had introduced him to Wallace Sabine in 1911. Now, Sabine was a Harvard physicist who worked in architectural acoustics. They hoped that Sabine and Guastavino could develop materials for their neo-Gothic ecclesiastical buildings. You have to understand that during the medieval era, all of the reverberations in these sorts of buildings were desired, but modern services focused on the sermon. You need a good sermon, or sorry, you need a good syllable articulation. And they wanted some sort of material that could help with this. So Sabine and Guastavino's first invention was Rumford tile, which was patented in 1914. You see it on the screen here at St. Bartholomew's Church in New York. Here's some detail images of those tiles. On the ceiling, it's really quite beautiful. They have these gold insets in the joints. Rumford tiles were a kiln tile. So they were produced with a mixture of clay and peat. And then when it was fired, the peat would burn out and it would leave behind these voids that create this sponge-like material with these chambers that absorb sound. Now, Rumford tiles were advertised well into the 1920s, but it was actually Sabine and Guastavino's second iteration of acoustical tile that outsold them. In 1916, they patented what was dubbed Akoustolith. In addition to having a higher sound absorption coefficient than the Rumford tile, Akoustolith was superior because it was a cast stone product. Now, Rumford tile, because it was kiln fired, it was less consistent. The irregular shapes and sizes and sound absorption coefficients couldn't be produced consistently as that material would burn away. But Akoustolith tile, the way it was made was that you had sand that was sieved, so it was all really graded to the same size. And then the particles were bound together with just enough cement and water, just barely to touch them. And that created this interlocking pore system that would then absorb the sound. And if you adjusted the size of the sand, you would change the size of the pores between the grains. And that allowed you to change what the acoustical properties were. This ended up being incorporated into train stations and swimming pools, theaters, factories, and it was instrumental in Cram's design for St. John's. The same year that the Akoustolith was patented, ground was broken for the cathedral. The nave that you see, the Guastavino vaults were constructed to support the entire floor of the nave. And then World War I interrupted fundraising. And it stood like, as you see it on the left of the screen, until 1925. And then began to rise above the floor. The vaults continued to be integrated into Cram's design because they embodied, his ideology for Gothic style, this concept of a load-bearing masonry construction that was free of steel, and therefore it was consistent sort of with the methods used during the medieval era. The footprint for that existing crossing dictated his design for the nave. So originally the cathedral was meant to be 500 feet long, and in order to keep the proportions for the Gothic cathedral that he wanted, he actually lengthened the cathedral to 601 feet, which if you need a reference point, think of that as 2 football fields and a football. The French Gothic style in particular was chosen to match the massive size and loftiness of it. The nave and transepts were designed on grids of squares, again, to maintain proportions he was looking for. Each of the squares of the nave is a sexpart type vault. You see these 6 sévres. The center of the nave soars to 124 feet. All of the ceiling of the nave is faced with Akoustolith tile. Wall is Sabine, advised cram on the acoustics, free of charge. By 1923, it had already been decided that they would renovate the Heinz and Lafarge choir so that it would be more in harmony with this Gothic nave that was going to be constructed. So a temporary wall was put between the nave and the crossing. In 1939, the nave began to be used for services and the ceiling was renovated in the crossing, or sorry, rather in the choir. The semi-dome at the end, which was to have mosaics, was removed and replaced with the 7-cell Gothic vault, which frames interior windows that are backlit. And then over the choir, there had been that red and green tile, which was changed out for these vaults. All of this was then lined with Akoustolith. Following the choir renovation, the entire length of the cathedral was finally opened on November 30th, 1941. The bombing of Pearl Harbor occurred a week later, though, and the construction of the cathedral was halted, leaving it in the configuration you see on the screen until the tower began on the south to rise in 1992. The interior of the cathedral remains much as it did when it opened in 1941. Cram passed away a year later in 1942. A few years after that, the reredos that you see on the left was removed. It had been long considered unsatisfactory, at which point the entire 601 feet of the cathedral was uninterrupted. And this view was at the time described as the longest unbroken vista in Christendom. And it's really amazing when you look down that full length to realize that really the entire ceiling and the floor is Guastavino vaulting. The Guastavino company remained in business until 1962, but was in decline in the last 2 decades. In 1945, Rafael Jr. sold the company to Malcolm Blodgett, who was the company's treasurer and financial manager. In 1950, Rafael Jr. passed away. After World War II, though, the company had closed their Boston, New York offices and really worked only on a few large projects from Woburn. The demise of the company is attributed to a lot of factors. The cost of hand labor, the rise of concrete shell construction, a shift in architectural tastes, the aesthetics, but also that by the 1930s, the Guastavino company primarily worked with returning clients who are also beginning to retire and pass away. Having brought you through that full history of the Guastavino construction at the cathedral, just want to briefly discuss a few conservation issues associated with the material and some of the things that we've learned working on these remarkable vaults. In 2001, a large fire occurred in the north transept, and following that fire, there was an effort to clean and restore the interior, which allowed us access to the Akoustolith for the first time really anyone had been able to touch it for about 30 years. So the first thing that was done was the cleaning of it. Because the material is so friable and absorptive, testing was done to determine appropriate product. Microabrasives, even soft media, would dislodge that sand and abrade that. Meanwhile, chemical cleaners would soak into the tiles and it would be difficult to actually get the chemicals out. So what we ended up using was a product called Arten Linde, which is a latex spray applied product here, which was sprayed on after cures pulled off, and then the surface was scrubbed with some water to remove the dirt. And that helped to keep the material on the surface of the tile. After cleaning, we sounded the tile. And what that involves is really just tapping on the tile with a non-sparking dead blow hammer. And what we do is we feel for changes in the vibration of the tile, as well as listening for differences in sound in order to determine if there's any variation of the tile that could suggest some sort of debonding from the backup. And so this, as well as a survey of cracks, was performed. There was no history of any tile falling in the cathedral, but nevertheless, after documenting these conditions, there were some areas in which we decided to grout. We started off in the choir, and the tile was actually grouted using a cementitious grout. Afterwards, we sounded. Everything seemed much more stable. It all went really smoothly. And then about a year later, we went to the nave, and the material performed completely differently. It started to come out the face of the tile, and after we sounded, it wasn't working as well. So we did analysis of the two tiles in the choir and the nave, and we found actually that they had different size sand. As I mentioned, you could change the particles in the material to change the sound absorption coefficients, and that's what had been done. And the nave tiles actually had smaller sand, they had smaller pores, and we believe the capillary action was actually pulling that grout through. So we changed to a different grout. We actually used a recipe that was developed by Morgan Phillips for adhering loose plaster to lath. And it's not available commercially at the time. It was actually mixed on site, but it's thixotropic. It would flow behind, but not out the face. There were tiles that we had to replace. Akoustolith obviously isn't made anymore. But what we did was we went back to the 1916 patent, and BCA digested some of the tile in our lab. We matched the sand to a local sand that was well sieved, and then the contractor made new tiles on site, and we installed those with just, again, they just had sand, cement, water, it's a pigment, and then where large areas were put in, we used a potassium silicate tint to create some variation in color. Last thing I'll mention is just coating of Akoustolith. As I mentioned, there's that, it was used in order to get rid of reverberations. However, that's very frustrating for a lot of church musicians. And so there's somewhat of a long tradition of them coating these sorts of tiles by Guastavino. In 1915, even before the nave of the cathedral had begun to be built, Bertram Goodhue had proposed putting a coating on some Rumford tile. Riverside Church in New York City sealed their tiles in the early 1950s and again in the 1990s. Nevertheless, this is somewhat of a controversial in the preservation field of changing those acoustics. We want to be very mindful here of not changing the appearance in any way. It's a very matte material that was used. The original material was selected from a variety that had been explored by the organ curator, Douglas Hunt, and he settled on an acrylic polymer. Once that he had set what had worked for the acoustical reasons, we then looked at it to make sure that it wouldn't have any adverse impacts. We evaluated its glass transition temperature. Essentially what we were concerned with is that because it gets really warm at the ceiling, we didn't want it to be tacky and have soiling sticking to it. We didn't want to start running and creeping on the surface. So we analyzed for that. We confirmed that that would not be an issue. And then they proceeded to coat the area you see shaded in red, just the great choir and the altar area, as well as the eastern end of the nave. The vast majority of the nave remains as it was installed. So we've reached the end of today's presentation. I hope that this gives you a greater appreciation for the history of the Cathedral St. John the Divine, as well as Guastavino construction. I just want to leave you with one parting thought, which is that, if the design had for the cathedral been fully realized, as far as Heinz and Lafarge envisioned it, it'd be very different. You'd have domes with all these glittering mosaics and colorful finished tile. And if it had been completed to cram specifications, it also looked very different than it does today. It would have had that, the huge spire. It would have a volume of 16,822,000 cubic feet and a seating capacity of 15 to 20,000. And although neither of those really grand concepts fully came to fruition, it's in large part due to their relationship with the R. Guastavino Company that the extent of those monumental visions could really be realized. And through the examination of materials at this cathedral, you're really able to see the remarkable evolution of the Guastavino Company and those technologies. So while their vaulting system is not only a dominating feature of the construction, we would contend that's also the unifying feature between these different designs and this extended construction period. I want to acknowledge the many people who have been involved in the various projects we described today, as well as some of the sources where we were able to glean so much of this wonderful information about the cathedral as well as Guastavino. Are there any questions?
Yes, thank you all for listening. And if anyone has questions, you can write them in.
Laura and Raymond, I want to thank you both. I'll say some more after the Q&A. but really to quote from you, Laura, the eloquent and informative way that you presented this monumental vision was so well done. So comprehensive, such vast knowledge, and we are very grateful to both of you. But now we will take some questions, and so just one.
Karen, may I have a
yes,
question?
Of course, please.
So thank you. That was spectacular and so thorough, and of course we learned so much. And as if we didn't love Grand Central enough and all of these wonderful houses of worship, I can't wait to go and look at the ceilings once more. Not that they don't always catch my attention, but I couldn't help but think so much about the workers. And yes, I'm here at the General Society of Mechanics and Tradesmen. I always think about the workers, but the laborers, you know, the quality control and being so up close and seeing this intricate work, both at, you know, initially, where did the tradesmen come from? Were they specially recruited? What was the calibration process for this to be done so skillfully and last for so long? And
yeah, well, that's an excellent question. We have some information, but not a lot of information. At least we don't, about who the actual workers are. We could see them in the archival photographs.
yes.
And it was a real mix in terms of immigrants, obviously, and the construction industry was full of immigrants who came here from either Spain or Italy or Ireland and Germany. So it was probably a mix.
And I did see that in the restoration, I saw Nicholson Galloway, and that would answer a lot of my questions with the quality of the firm, the exquisite work. And so that was wonderful to see. And I do have an homage to the building trades. Always stunned when even our historic structure here, which we look forward to your coming to visit, and Raymond, to welcoming you back. It's, we're always grateful to those tradesmen, because it's incredible how these structures, being so well built, live on forever. And of course, with our maintenance. But I just want to go to something a little lighter. The Whispering Gallery. How was it originally discovered? That whole phenomenon.
I don't know. Can you hear me, Victoria?
Yes.
Okay, so not sure how it was discovered, but it's been a as I mentioned, it's been a tourist attraction for many decades. And it was probably accidentally discovered. I mean, this was never intended.
Right.
And so, this curiosity has become sort of like a real attraction for another attraction at Grand Central Terminal. And I have to tell you that when we took down a lot of the tile in the Whispering Gallery, which is just to remind everybody, is just outside of the entrance of the Oyster Bar, there was a lot of trepidation about whether we would be able to put it back in a way so that the whispers would still be able to be heard after it was all reconstructed. And we really struggled to get every detail right, to get the thicknesses as close as we could to the original when it went back in. And in fact, we created a mock-up, a full-scale mock-up of one part of the Severy of the Whispering Gallery in order to test it and make sure that it was still functional, which it was before we reconstructed everything. So a lot of attention was paid to getting that right, and it still continues to this day to be an attraction. People walking up, you think they're walking up to the Oyster Bar, and they're really going into a corner. It must be, it's in the guidebooks.
Yes, I see it all the time, because I have to pass through Grand Central quite a bit, and there's always someone checking it out.
That's quite something.
Right. Well, if we'll take a few of the audience's questions. This is from Ricky James. Does the architect design his patent value in any other style than Gothic architecture?
Laura, you want to answer that?
Oh, I mean, no, if you take a look at as far as it is, you mean where else was used? I mean, it was the Gothic architecture actually initially was the reason why it, let me rephrase that. The Beaux-Arts architecture is really where it started. And with these large domes, these pendentions, these tunnel vaults, and then that ended up expanding to be the Gothic architecture. And you can actually make all sorts of other forms of it. There was an image on the screen I'll try and bring back, in which people have done others. But Gothic, it's just neo-Gothic architecture was so major during that period that it became just such a prevalent means. And the architects that were using it were these repeat customers that were again contacting him. I'll bring this back up.
Karen, you're muted.
This is from Paul Napperstek. How long was the infinite corridor at MIT at the time that St. John Divine was built, that was declared to be the longest interior view in Christendom?
Well, I don't actually know the answer to that, but I'll have to check that out. No, I'll have to look at it. That's a great question. I don't know.
I have to say there are always challenges to whenever you say it's the longest or the biggest or whatever it is. You know, there are certain dimensions where, you know, the Cathedral of St. John of Divine is the largest cathedral in the world, depending on how you measure it. So, so there are always challenges, but it's good to hear about those. We'll look into it.
What are the future plans for the cathedral? Do you know?
Well, that's a great question. It's a little hard for me to answer it, you know, since I'm not the rector or the pastor there. But we've been involved there, as I said, for, you know, well over 25 years. And I can tell you a couple of things. One is that the cathedral has always been committed to the preservation of the building itself, to the fabric, as it's called, the structure and the material, the fabric of the cathedral. And that commitment to preservation has made our work that much more enjoyable over the decades. That attitude has never wavered, even in hard times. And we can say with confidence that, based on everything that we know, that the cathedral will continue to maintain itself in the future. Now, whether, you know, in the 80s, there was an effort to begin reconstructing, to complete the towers at the front of the cathedral. And the South Tower, it's in actually one of my photographs that I showed, but I didn't point it out. There was an effort to begin completing those towers based on the original design. And that effort lasted a few years, and then, you know, it became financially impossible to continue on. So the South Tower is actually higher than the North Tower. And that's because of that effort. Those kinds of, and during that process, during that effort, there were a number of apprentices that were trained from New York City, from the surrounding neighborhoods around Morningside Heights, were trained in stone carving. It was a monumental effort. It was a fabulous thing to witness. You know, I was just out of graduate school when that happened, but it was a fantastic thing. So the cathedral, you know, has continued to look at how it will build itself in the future. The question as to what can happen at the dome or above the dome is something that, you know, perhaps has been studied. I know it's been studied, but the Guastavino dome is a character defining feature of the building now. So it's an interesting puzzle, as I say, for a preservationist as to what could or should happen there in order to comply with the architect's original vision of having a spire above where the dome is now. So that is unresolved and it's really for future generations to figure out.
Thank you. Thank you for that very fulsome answer. Thank you. Is there an historic precedent for the material and method? Is there any structural relation to Brunelleschi's Duomo in Florence? Forgive me for mispronouncing that.
Can you repeat that question? I didn't hear the end of it.
Is there any structural relation to Brunelleschi's Duomo in Florence? D-U-O-M-O.
Oh, the Duomo, yes.
Duomo.
Yes, yeah. Okay, aside from the fact that it spans a very large area, I can't think of anything that is where the similar, I mean, in the use of masonry materials, that's where the similarities end. The Duomo is hundreds of times heavier than what would have been a Guastavino vault over the same area. I mean, it's just vast amounts of masonry. And it took, I think, 15 years to build, if I'm not mistaken, whereas the dome over St. John the Divine took 16 weeks. And the sheer weight of the Duomo is, I forget how many, millions of tons of material there is, and whereas at St. John the Divine, it's a fraction of that amount. And that is because the Duomo was constructed with full-size masonry units, full blocks, brick and stone. And, they were building it at a fairly high level. And so all of that material and workers had to be elevated up to that area. But that's true also of Cathedral at St. John the Divine, which was built a lot faster. So that comparison really illustrates what Guastavino was selling, which was we can use less material, we can build it faster and for a lot less money, and without the need for any kind of centering or support structure underneath the vault while it's being constructed.
The dome actually was, they had looked at two options for covering the crossing. And one of the options was with a steel frame and such. And the reason that it was built with Guastavino was because it was cheaper. They didn't need the scaffold inside. So it was the cheapest option.
Yeah. Good question.
We'll just take a couple more questions. Is the St. John the Divine dome the largest span of Guastavino tile?
It is. It's their largest dome.
Okay. This is from Laura Ottersten. Out of restoring existing work, are timbrel vaults being built as part of new structures? She asks why.
Well,
I don't think so. I don't, not to my knowledge. It'd be wonderful if it were.
You
if they were, maybe there will be.
There's some, there's, workshops and people still work with it. And I'm just going to quick bring up, there was, as far as this installation dates from 2015. And you see, I mean, this is just beautiful. Going to the, can it be used for anything other than Gothic vaults? Yes, definitely. You could make all sorts of shapes with it. But whether or not people are actually using this, again, there's a cost value now for the hand labor. You certainly could be constructing other things cheaper in concrete. So there's certainly a skill level, but there is certainly interest amongst a group of people of trying to employ this material. But as far as large installations, I don't know of any.
Well, it's interesting because, for instance, there is a revival sometimes of traditional building materials like terracotta, for instance, which there's been a recent revival in the use of terracotta. For instance, at One Vanderbilt, the facade of the building is largely terracotta, which is amazing, considering that it's a tower in New York City. So there's still, a lot of possibilities for Guastavino vaults to be installed, or, covering open areas and public spaces. And hopefully, you know, maybe somebody listening to this presentation will be inspired, an architect, to incorporate it into a new work in the future. There are masons who can build them, and we're pretty confident of that.
Thank you. This is from Jose Hernandez. Any congratulate you, wonderful presentation. One question: were there any changes in the formula manufacturing during the replication of the? Sorry, the question has just leapt out of my way. Of the Akoustolith to improve its performance with the cohesive tile construction.
The question, you kind of broke up a little bit. The question is, was there a change in the composition of the Akoustolith?
Yes, to improve its performance with the cohesive tile construction.
Yes. Well, I'll let Laura answer that question. She is the expert on Akoustolith.
So there were definitely variations with Akoustolith that they would do it. Again, they could change the properties by changing the sand. One of the patents actually shows it so that they would have throughout the layer of a tile, the pore sizes change. And I've not ever gotten to see a thin section of one of those tiles. So they had a lot of different variations, but the formula was generally the same, where they would use a very consistent ratio of the sand to the cement and then just enough water to get it to all bind together. So that was very consistent. As far as when we did the restoration, I don't know if this would be asking as far as changes and such, when we did the restoration, because we were not trying to mimic the acoustical properties, we were really interested in the visual properties. The contractor actually made them slightly more dense to ensure curing of the material. But again, we had the visual aspect that we were going for.
Right. I thank you, Laura. This is from George Monasterio. What was the source of the fire at the cathedral, since all its masonry are non-combustible? Do you know what the cause was?
Yes. So the fire occurred in the north transept, and I'll just see if I can quickly get us to that image because it'll make more sense looking at it. Because the cathedral was all masonry is why they were actually able to fight it back the way they did. So this area of the north transept was constructed at the same time the nave was. But what happened was that they had foundation issues again. It didn't rise as far. It only got to 40 feet. So when the cathedral fully opened, it was only about 40 feet high. And then again, construction stopped because of Pearl Harbor. And so it just sat there. And so they ended up covering it with a temporary roof that was a bitumen covered wood, had wood in it. And what happened was that in the very corner of this, there was a electrical strip that essentially started the fire overnight. And that roof then burned, it broke through the windows of the crossing and then filled the entire cathedral with smoke. However, the amazing, when you hear people talk about the firefighters coming in because they were able to go on the crossing, actually fight the fire back from the crossing and were able to put it out, but the entire cathedral therefore filled with smoke. But it was in fact, that roof, really, that's all the burn. And because there's no pews in this area, here, this is what I was going for. Sorry, it took a long time, I flipped quickly, but this is the roof that actually burnt. And so this was the area that broke through these windows. They fought the fire back, but because this is all masonry, it really just needed to be cleaned. There wasn't damage to this actual structure. It was just this area.
So the interesting thing is that the firefighters had to fight the fire from inside the building, from within the building itself, because the fire started from essentially outside of the nave and broke through the windows. But the smoke, as Laura said, literally covered every square inch of the cathedral and found its way even to the top of the vaults.
And if you may recall, some of you may recall the newspapers, it was actually just a few days before the fire in Notre Dame in Paris. There was another fire at St. John's in 2019 that was in the crypt. It was under St. Savior, which is that first chapel we mentioned. And they were able to put it out relatively quickly. Nevertheless, again, the building filled with smoke, but it was underneath, you know, a Guastavino floor system, and those vaults, despite having the fire directly underneath it, completely fine. So again, smoke being the issue, but really remarkable that they have this construction.
Absolutely. This will be our final question. This is from Rachel Killion. I'm interested in more information on the Guastavino's firm. Can you point, Rachel, in the direction of any researcher or literature? Well, that would probably be you, Laura. We have a small vault, 1904, at a pumping station here in Attleboro, MA, Massachusetts, attributed to them. And I'm curious if the firm did smaller projects or if the tile was sold to other builders.
Well, to my knowledge, I don't know it being sold to other builders, but they certainly did projects of all sizes. And the most wonderful book that we can recommend is Guastavino Vaulting, The Art of Structural Tile by John Oxendorf. There it is. I was looking for it on my shelf above me. Ray has it, which is an absolutely remarkable resource. And also in the back of it has a catalog of known constructions. So you'd be able to look up to confirm the construction of that site.
Well, thank you. And perhaps we will include the title of that book when we send out the video recording to registrants. So Raymond and Laura, what an absolutely fantastic presentation. As I mentioned before, it was done in such depth, so informative, but yet complex information presented in a way that we could all understand, even if those of us who are not architects or conservationists. So really, it was absolutely fantastic. And we are so delighted that you have been part of our lecture tonight. And again, I do want to express our thanks to both of you, but also to Beth Bailey, who was instrumental in setting up this talk. Victoria, would you like to add a few words?
Yeah. Well, as I always say, Karen says everything so beautifully, she leaves little on the table. So I will say that Karen, I completely agree. And thank you for making us not only, nourishing our minds and our souls with this information, but making us curious and wanting more. So thank you. Always a great thing. We can't wait to go looking and reading. Thank you.
Well, thank you very much. I mean, there was a lot of information in this presentation, but there was a lot that we had to leave out.
Yes.
So your curiosity will be well rewarded by further looking into it and looking around at these wonderful constructions. Incredible.
Yes.
Absolutely. And thank you really for celebrating the work of Guastavino and using the mythology of St. John's Cathedral the Divine to do so. I want to say, for those of you who weren't, whose questions we weren't able to answer, I will forward them on to Laura and Raymond. And to you, the online audience, I want to thank you so much for being here tonight and supporting the lectures. And I want to mention that our lecture next week is on a very different topic. It's the impact of the Huguenot refugees and how the wonderful arts and cultural things they created from like 16th century to the 19th century. So I will now say a final thanks to Raymond and Laura. And again, thank you so much for being part of our lecture tonight. And we look forward to seeing you at the General Society in person at some point. Absolutely. That would be lovely. So anyway, thank you so much. Good night. Good night, everyone.